Okay, hi everyone. We are continuing on in chapter 2. We're now on page 23 and in section 2.5, learning a little bit about interpreting graphs. Just want to kind of hammer home the point here in section 2.5 about what are the appropriate graphs to use depending on what type of data you have. And then also go over a little bit about some misleading graphs and things you really should never do, and also be careful of when you're looking at graphs. So appropriate graphs, recall the type of data you are dealing with determines the type of graph you should use. So for numerical data, we either want to use a dot plot, a histogram, or a stem plot. Now the histograms are the most common, especially for large data sets, and that's usually what we'll work with. For categorical data, the pie charts and the bar graphs are the two types. Bar graph is most common. It's similar looking to histogram, although not the same at all. We've talked about that. But and pie chart is not as commonly used. It's kind of a nice thing that people like to look at because it looks cool, but it's hard sometimes to see the mode and the variability in a pie chart because of the slits of the pie are just not, you can't see minor differences with your eye. So appropriate measures. Now also remember that when we're describing numerical data, we want to look at shape, center, and spread, which means horizontal spread. And for categorical data, we only want to look at mode and variability. And for variability in categorical data, we really mean diversity. Okay, now misleading graphs. Well-designed graphs help us see patterns, but misleading graphs play tricks with our eyes and lead to wrong conclusions. So here's some examples of some misleading graphs. The first type of thing you don't ever want to do is what's called inappropriate scaling. That means starting at a value other than 0. So in example 25, these graphs are actually right out of page 58 of your text. They show crime rates over a 5-year period. So what do you notice about the graphs? And what do you think is the aim of the first graph? Hopefully everyone can see right away that we have violent crimes. Now this is the same data. It looks quite different. Well, what's the difference? In the graph on the left, they don't start the vertical axis at 0 like they really should. You can see a decline in both of the graphs in violent crimes. However, it looks much more dramatic in this one. So probably the aim of this graph was for the author to say, hey, we got a really dramatic decline, and maybe that's not the case. So it seems more dramatic than it really is. You have to be very careful about that. The next thing is to use icons of different sizes rather than bars. We have to be very careful. Again, this is misleading. So what's wrong with these graphs? Well, let's look at this one. Here's a pie chart that doesn't equal 100%. That's ridiculous. You can't do that. We have 100% of a piece of the pie. That's it. Here's, again, vertical axis not starting at 0. Makes it seem like a dramatic increase, when perhaps it's not really as dramatic increase as it looks. In this example, we're using icons. Icons should really never be used. They're just hard. They're usually not proportionally correct. They're people trying to get you to mislead you to think that one is really bigger than, way bigger than the other. It's just, icons are not a good idea for really good graphs. And here's something that's interesting that they did. Notice that 0 is at the top and we're working downwards positive. Usually we don't do that. That means we've kind of flipped it over. And when you first look at this and you see it's about gun deaths, you're like, oh, gun deaths went down. No, that's an increase actually. So we have to be very careful. 0 at the top of the vertical axis. In other words, it's flipped over. This could make you conclude quickly and incorrectly that the number of murders decreased. Be very careful. These are all examples of misleading graphs.